Hello, I'm Mr. McBrien. This is TEJ20, Troubleshooting. So we start today with the second law of thermodynamics, and this states that entropy increases in natural processes. Wait, what does that mean? Disorder increases over time, or stuff happens. Today we're going to talk about what to do when things go wrong with our computer. The Ontario curriculum states that we're going to be able to connect and configure the hardware for a personal computer system and install an operating system. Well, in order to connect and configure these things, we have to actually deal with the situation when something goes horribly, horribly wrong. So again, we start with that second law of thermodynamics. Computers fail, and they fail maybe not as much as they used to, but they still fail a lot. So what causes these failures? When it comes to hardware, wear and tear, dust is a big culprit. Issues with interrupted electricity for various reasons, and jostling, bumping computers can cause hardware failures. Software, we see issues with corrupted files and with malware. No great shock. The biggest key to preventing a disaster, whether natural or otherwise, is preparing. So we can have hardware failures. They don't have to be a complete disaster. So the first thing we want to do is make sure that we do backups. And we're going to talk more about backups in a later point. But backups are a key part of responsible use of computers. We'll come back to that in a minute. And then we're going to return to that in a couple of days to talk about the mechanics of backups. Now, diagnosing problems can be a significant challenge. If you check online, you can find various diagnosis flowcharts. If this, then do this. There are a lot of things to go wrong, and we can't cover how to solve each one of those in detail in one set of slides. Now, sometimes things are going to be pretty easy to diagnose. For example, if the computer starts up and the operating system fails to load, we investigate things associated with that aspect. When Windows tells us there's a print error, we know where to go to start looking for the problems. But sometimes it can be a little less easy to diagnose. If you have a blank screen, why is that? In any case, the process of diagnosing a problem involves first collecting as much data as you can. Then you can form a hypothesis, and then you can test that hypothesis in various ways. Notice that this is closely related to the scientific method. Now, the internet, it's our first instinct in this day and age to head straight to the internet when we see a problem to try to help us to diagnose it. And in fact, Google searches are a powerful diagnostic tool. What you want to do is describe everything you know into your browser and review the advice with a grain of salt. Just don't do what they tell you instantly, but actually think about what you're seeing to decide if it's right for you. But first and foremost, you need to collect data before a search is going to help. Garbage in, garbage out. When we want to fix hardware issues, true hardware failures are fairly rare, with some exceptions. Hard drives last you about roughly 5 years. RAM will last you a lot longer. In the absence of physical abuse of hardware components, typically the failures are rare. When they do fail, it's usually easier to fix than software issues. Now, when you want to confirm a hardware problem, The easiest way to do this is to have a working version of that hardware, swap it out to confirm that it addresses the issue. If you don't have a working version of that hardware, it's not ideal to go and buy a new version of it in order to just test a hypothesis. The most common hardware issues, I'd invite you to think about that right now. So what do you think are the most common things that can go wrong with hardware? Pause the movie if you want to and see if you can come up with some answers to that question. Well, hopefully the first thing you came up with is cables. So virtually any IT manual on helping to troubleshoot things first says check the cables. In fact, they're a very common problem, but there's a second piece of that puzzle, and that is that they're extremely easy to fix. So you can diagnose cables extremely easily. So whenever you see an issue with, for example, a blank monitor, hey, make sure it's plugged in. Make sure it's plugged into the wall. Make sure it's plugged into the computer. Hard drives, as I said, have an average lifetime of about 5 years, so they can certainly be things that fail. If a computer has just been transported, and this goes back to data, right? Collecting data. If a computer was moved from one office to another office, it isn't uncommon to have a card get slightly dislodged. It seems to be still in place, but it no longer is being recognized by the BIOS. Well, reseating cards can sometimes solve an issue. Now, dust is always an issue with offices, and even more of an issue if you're in a location like a factory or something like this. So fans will tend to fail, again, with the moving parts. Cleaning dust out of a fan can sometimes solve an issue. Power supplies last a long time, but not forever. Again, when you think that something is wrong, check its cables before you decide that that piece of hardware has failed. Now, when it comes to diagnosing a given piece of hardware as having failed, the BIOS is a tremendous help to us. Why? Because of that power on self-test. The post-test at the beginning checks a large number of hardware components to make sure that a computer is going to work when the operating system is booted. Now, the post doesn't just check and then shut down. It in fact writes its report to the BIOS. So that is available to you later such that you can check on it. So if things go badly, if the operating system doesn't load and you're trying to figure out what's going on, you can look at the report from the post and see what might be happening, right? So if the RAM isn't shown under your components, this can give you a hint as to what's going on, for example. By the way, if your computer is starting up and then shutting down after it has run for some period of time, this can be due to overheating of the CPU. The BIOS is helpful in this regard as well because it records the temperature of the CPU. So there are lots of amazing clues that can be available if you enter into the BIOS. Now, hardware failures, I mentioned, most of them are fairly rare. Software issues are maybe a bit more common. So we can have software issues with drivers for given components, and these drivers can be disabled in one of two ways. They can be corrupted if a given sector where it's located on the hard drive is destroyed, or sometimes drivers will automatically update and the update will disable the component. Similarly, we can have issues with the Windows registry, and if this becomes corrupted, it can become a major problem. And then, of course, there's also malware. And we'll talk about network security soon. When it comes to restoring functionality with software issues, we will sometimes repair specific systems by reinstalling drivers, by repairing the registry, and sometimes we'll restore the operating system from backups, which we'll talk about a bit more, as we mentioned. In a worst case scenario, we start all over again as if it's a brand new computer, and we reinstall everything from scratch. We'll do everything we can to avoid that situation because it represents a great deal of work. We need, though, to diagnose the issue before we decide the action we're going to take. Now, if we do have to restore our operating system, for example, if Windows is hopelessly corrupted, or if our hard drive is completely failed, this is where preparation is going to help us a great deal. If we have to restore Windows completely from scratch, this is typically a lot of work and a lot of stress. However, we've already talked about retaining our original Windows ISO for a given computer. We've talked about making a Windows system image when we have that ISO installed to the place we want it to be. We've talked about saving the drivers for given pieces of hardware. And we've talked a little bit about backups of files, and we're going to talk a lot more about that in coming days. If you do these things, particularly if you've got a current or a recent Windows system image, plus backups of all of your key files, you can have your computer up and running from a hard drive failure very quickly and easily. So these are some of the things you want to do if your computer is important to you. If you have that Windows system image, if you have backups of key files, you can restore a system from a hard drive failure extremely easily. Okay, so that's a quick walk through troubleshooting. Key points here: things break, you need to plan for it. So prepare for problems by making backups. When you do see a problem, use the scientific method. Collect information, make a hypothesis, test that hypothesis. Check cables before anything else and connections between cards and the motherboard. Review the BIOS to help you figure out what hardware is working and what isn't. Do Google searches, but collect data first. Don't do them blindly. You can check to see whether software has been updated. And part of your diagnostic process can be swapping out potentially non-working parts for known to be working parts. Update drivers where hardware might be functioning and you're not sure. Okay, so today's activity is one of learning what a failure looks like. So you've got your working build computer. What I'd like you to do is disable this computer in very targeted ways by, no, don't break individual hardware components. Don't destroy your hard drive, for example. Instead, unplug it and see what it looks like when a hard drive with your operating system has been unplugged, simulating a hard drive failure. If you don't want to unplug it, you can just disconnect the power from your hard drive, for example. And once you do that, power up your computer and look at what happens. See the symptoms. Then you're going to know what a failed hard drive looks like. Fix the issue with the hard drive, verify that it's working correctly, move on and check something else. Unplug the RAM. and see what happens. By doing this, you can essentially get years of IT experience in 1 or 2 periods. So I challenge you to record the symptoms of each kind of failure and see how many different ones you can record in 1 period. Okay, that's all for today. Thanks very much, and have a great night.